So now we know all the ins and outs of calculating angles and sides using the primary trig ratios. Let's start applying these to some word problems. Let's do a quick review first so we make sure that we all have everything under control. We remember exactly what we're supposed to remember. So the three primary trigonometric ratios used to solve what? Well, we're used to, where's my pencil? There it is. We're using it to solve different sides and angles, as I said a second ago. Great. And how do we do that? Well, we're going to look at a triangle like this. It has to be a right-angled triangle. That is absolutely key here. It must be a right-angled triangle. Now, if it is a right-angled triangle, all I need is one angle to kind of align everything within the triangle. So let's say C is our reference angle. So if C is our reference angle, I'm going to label my triangle according to opposite, hypotenuse, and adjacent. Opposite is always the side opposite across the triangle from the angle we're referencing, in this case angle C, so this would be our opposite over here. Sometimes we'll just write an O. Our adjacent is the side directly beside the angle C, so it's actually touching. But some of you might be like, wait, this side over here is also touching. Well, that side is always our hypotenuse, and we know it's always our hypotenuse because it's always the opposite side from the 90-degree angle. So this is always our hypotenuse. Okay, so we've labeled our entire triangle. From here, given our reference angle, and depending on what data we have, we're either going to use sine, cosine, or tangent. And we know which one to use based on the data we have and our little acronym we have over here, SOHCAHTOA. So we're going to use sine when we are dealing with opposite and hypotenuse. We're going to use cos when we're dealing with adjacent and hypotenuse. And we're going to use tangent whenever we have opposite and adjacent. So let's formalize this down here. So sine of theta, theta being any angle. The sine of any angle is equal to our ratio of opposite over hypotenuse. It's always the first letter over the second letter. So opposite over hypotenuse. And for our cos of theta, that's always our adjacent over our hypotenuse. And finally, our tan of theta is always our opposite over our adjacent. There we go. So now that we've cleared all that up, I want to draw a picture for you. Imagine that you are standing on top of this big hill. And this hill leads into some water. Very beautiful. There's a boat down here. Woo, we got a boat. Nice little sailboat here. Okay. And maybe up here we have a bird. Tweet, tweet. And you're standing on top of this hill. Now, when you look straight out, we create a straight line as such. Okay? However, if you look up towards the bird, we create a different line. So this, if we're looking up towards the bird here, there's an angle created between the direct horizontal line and the angle that we're looking up. This angle here is called the angle of elevation, sometimes called the angle of inclination because you're inclining. It's an incline, inclination. However, if we are looking down towards the boat, imagine we're looking straight line over here. The angle that we have down here below that horizontal line, this is called our angle of depression. Or also called our angle of declination, decline. So you're either inclining or you're declining. Declination. All right, so it could be either or, angle of elevation, also known as angle of inclination, or the angle of depression, also known as the angle of declination. So it just means the angle relative to that horizontal line. Are you looking up or are you looking down? So this is when you're looking up, and this is when you're looking down. Okay, so just to formalize these, the angle of elevation or inclination is the angle measure above the horizontal line to the sight line. And the angle of depression is the angle below of the horizontal line to the sight line. Now, I purposely drew this picture over here because depending on your photocopy of your course notes, this picture may not actually be all that clear to actually see. So if you're looking up from the horizontal, elevation, down from the horizontal, that's depression. So let's give this a try. So the angle of depression, so we're looking down. So the angle of depression from the top of a ski hill. So imagine we have a ski hill, goes in a nice line down here. And you're looking at the top of this ski hill. So it's the angle of depression from the top of the ski hill is 24.6 degrees. So if you're at the top of the ski hill and you're looking straight out, and then you look down, so the angle of depression, that's the angle right in here. This is 24.6 degrees. That's the angle right there, 24.6 degrees. The length of the hill itself is 168 meters. Okay. What is the drop in altitude of the ski hill, rounded to the nearest meter? Okay, so first of all, what do we mean by altitude? Altitude is just a fancy way of saying how high something is. So basically we're asking how high is the hill. So if I dropped a straight line down the hill, and we drew it out like this, basically we're asking is, what is this value over here? We can see that that's a right angle. So our let statement is going to be let x be the altitude or the height. Oops. Be the altitude. And brackets, I'm going to write height, just so you guys have that in your notes, of the ski hill. Okay, so now let's look what we have here. We have this angle up here, 24.6 degrees, but I have this triangle down here. Does that help me? Now we got to go back to our old triangle theorem rules. I have a perfectly horizontal line here, and I have a perfectly horizontal line down here. You know what I see? I see a Z pattern. So down in here, this is also going to be the same angle. This is also 24.6 degrees. Ho-ho! So now we have an angle and a side. So if this is our reference angle, we can label our triangle. Our opposite is over here, our adjacent is down here, and our hypotenuse is over here. So we have the hypotenuse. Actually, let me just undo that. We'll use a highlighter. We have the hypotenuse, and we're looking for the opposite. So, pardon the phrase, SOHCAHTOA. Which one are we going to use? We have the hypotenuse and we're looking for the opposite. So that means that we're going to use sine. So our sine of our reference angle, so our sine of 24.6 is going to be equal to our opposite, which is x, over our hypotenuse, which is 168. We rearrange and solve for x, so that means we cross multiply. We end up with x is equal to 168 times sine of 24.6. So when you do your math here, you're going to end up with x is going to be approximately 70 meters. How do I say 70 meters? Because it says round to the nearest meter. And that's the whole thing. So this is going to be the steps for all these problems. First thing we're going to do is we're going to read the question and we're going to draw a diagram. We're going to calculate or find out any unknown information or simple calculations that we can actually do. And then once we're that far, then we're going to determine whether we should, which primary trig ratio we should actually use and solve for our unknown values. That's generally speaking the goal. Once you've done that, make sure to give a concluding statement. Therefore, the height of the hill is 70 meters. There we go. Not too bad. Let's go down and try one a little bit more challenging. We'll go to this one. Number 2. Cathedral Grove is a rainforest with many cedar trees. One of the cedar trees stands approximately 100 meters tall. Okay, so let's draw our 100 meter tall cedar tree. So you are going to go right here. And I know that you are 100 meters. I'm going to back that up, see if I can do it slightly better. ish. I think that's actually worse. Whatever. So that's going to be 100 meters tall. If you are standing 35 meters from its base, so 35 meters, the base is down at the bottom. So if we're standing this far, 35 meters, this is us. We're standing right there. From its base, what is the angle of elevation from the ground to the top of the tree? So remember, elevation is the angle up. So that means we're looking up. So it wants to know this angle here. Okay. Well, clearly the tree is standing straight, so we're going to say that's a right angle. We're going to have a let statement. What is our let statement? It's going to be the angle that we're actually looking for. So let's use theta. Let theta be the elevation angle from the ground. There we go. So now we want to, since this is our reference, there's our theta, this is our reference angle, let's fill out what we can. So let's label our triangle. Our opposite is over here at the 100, our adjacent is down here at the 35, and our hypotenuse is our hypotenuse of the triangle, of course. So what do we have? What are we looking for? Well, we're looking for the angle. We have the opposite, and we have the adjacent. So what works with our SOHCAHTOA? Opposite and adjacent. There it is. So that means we have to use tan. So let's set up our trig ratio. Tan of theta is equal to our opposite, which is 100, over our adjacent, which is 35. Now we got to rearrange and solve for theta. That means we're going to use tan inverse. So theta is equal to tan inverse of 100 over 35. Now this is to the nearest degree, so don't forget to round to the nearest degree, the nearest whole number. So when you put that into your calculator, you should end up with a value of approximately 71 degrees. That's quite the angle of elevation, really looking up. But I guess you're not too far away from the base of a 100-meter tall tree. That's a really big tree. So therefore, the angle of elevation from the ground is 71 degrees. Okay, so again, you saw that the solution to this problem was largely the same. We read the question, we created our triangle based on what we have, made sure it's a right angle triangle. We filled out all the data, we highlighted the information we need, we highlighted the information we have, and from there we chose a primary trig ratio, filled in all of our values, and calculated what we needed. Okay, let's move on. So this question, I want everybody to pay attention to this question. And the reason why I say that is because in all the times that I've taught this course, I have seen this question come up in homework, I've seen it come up in practice, I've seen it come up in reviews, I've seen it come up in tests, I've seen it come up on exams. It's a very common question for this setup. Now, I'm not talking about the exact wording, but the idea of setting up two triangles from one object to another object and calculating unknown data between these two. So this is a very common setup. So I want you to really pay attention to what we're doing here. Okay, so imagine that we have a video camera, and that's going to be mounted on top of a building that is 120 meters tall. Now we can see that this is the 120 meter tall building. So that's going to put the camera right there. That's our camera. There we go. All right, so the angle of depression from the camera to the base of another building is 36 degrees. Filled out nice for us. We can see that, 36 degrees. The angle of elevation from the camera to the top of the same building is 47 degrees. Okay, so we got a multi-part question here. First, it's asking us, how far apart are the two buildings? Round your answer to the nearest meter. So we have to figure out what we're actually trying to solve here. We're trying to find the distance between the two buildings. Well, that is this line right here, the one that's going perfectly horizontal across. And we can see that we've created two right angles. So let's call this our x. So let's say let x be the distance between the two buildings. between the buildings. Okay, so now that we have this, what can we solve? Well, we don't really have a lot of data. We have a couple angles, but I don't see any side lengths on these two triangles. Can we get any side lengths? Sure we can. Sure we can. Let's look at our bottom triangle because it's the first one that we got information from. Do we know any information here? We know that this small building is 120 meters and the camera is at the very top of that building and it goes down to the ground. That means that this 120 meters also applies to the side over here. This is 120 meters as well. Okay, so now we have a length and we have an angle. Ho ho! So with that information, that means that we can actually calculate our x value. So I'm going to switch to a red, and so I can actually properly label our triangle. So if this is our angle of reference, this 36 degrees, that means that our opposite is going to be the value that we're looking for. Our hypotenuse is always opposite of the right angle, and that means our adjacent is the x component that we're looking for. So that's what we're looking for. This is what we have. We also have our angle of 36 degrees too, but so we're talking about OA, SOHCAHTOA, TOA, that's tangent. So we can set up our math right away. So we have tan of our reference angle, which is 36 degrees. Okay. And we are going to set that equal to opposite, which is 120 over our x. We know how to rearrange this. Basically, the tan and the x are going to swap spots. So we have x is equal to 120 over tan of 36. Now, when you plug this into your calculator, you're going to get a number that, remember, it says round to the nearest tenth of a meter. Tenth of a meter. Tenth is 1 decimal place. So that's 165.2 meters. And that's the whole thing. That tells us the length in between the two buildings. So I can give a good, nice concluding statement. Therefore, the buildings are 165.2 meters apart. Okay, follow-up question. How tall is the building viewed by the camera? So basically it wants to know the entire height, h here. Well, we know that the piece at the very bottom here is 120, so that's pretty good. But I don't know this piece up here. So let's start off by labeling this. Let's call this y. So let's say let y be the height from the top of the smaller building to the top of the taller building. Top of the smaller building to the top of the taller building. The top of the smaller building to the top of the taller building. So what does this mean? That means this value right here, let me just write this a little bit better here. That means that the distance here from the top down to here is going to be our y component. So what is h? H is 120 plus y. So we know that h is equal to 120 plus y. But I got to calculate y. Can I do that? I can, because I have an angle and I just finished calculating x. So I now know that that value is 165.2. So I can actually do the math. If 47 is my reference angle, opposite is our y, our adjacent is our 165.2, so the a is still there, and our hypotenuse is right here. So what do we have? What are we looking for? We have our 165.2, which is our adjacent. We're looking for our opposite. So what do we got? Opposite and adjacent. That's tangent again. TOA, 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 TOA. So tan of our reference angle, which is 47, is going to be equal to our opposite, which is y, over our adjacent, which is 165.2. Now we can rearrange by just multiplying both sides by 165.2. So we have y is equal to 165.2 multiplied by tan of 47. All said and done, y is going to be approximately, 177.2 meters. Well, that's good, but I wasn't just trying to calculate y, I was trying to calculate the height. So that means we got to substitute that in. So h is equal to 120 plus 177.2. So h is going to be equal to, now it's approximate because 177.2 is rounded, that's going to be 297.2 meters. Not bad. Okay, so now we need a concluding statement. So therefore, the height of the taller building is 297.2 meters. It's a tall building. They use a lot of tall objects in these examples. There we go. Alrighty. So that is our last word problem. The next problem is, as it says, a challenge question. This is what we would consider a thinking problem. All right, so this would be a thinking question on your tests or your exams. Okay? Pardon me. So it says, solve the following triangles for x and y. So we're going to try and find x and y. Round the answer to one decimal place. So we got to find x and y. So there's x and there's y. So can we calculate anything else in here? Well, we definitely don't have enough information to calculate anything directly because we only have a part of a side length. We got a part of this non-right angle triangle. That's not really helpful. I know that this whole distance down here is the sum of these two. So I know that this whole thing is 20 plus y, but that still doesn't allow me to calculate anything directly. So let's think about what we can actually do here. Now, I want to calculate x, and the only angle I have is this 68. So if we label our triangle based on this 68, then our opposite over here, our adjacent is down at the bottom, and our hypotenuse is up top. So the only values we have, we don't even have the hypotenuse, but at least we have letters for the opposite and the adjacent. So that's OA, so that's tangent, TOA. So let's create an equation for that. So we have tan of 68. When you don't have the direct data to calculate something, start writing information that you can possibly work with. And so that's going to be equal to our opposite, which is x, over our adjacent, which is y. All right, well, let's rearrange this so we can at least get an equation that's useful. So if I want to rearrange for x, or isolate for x, that means I'm going to multiply both sides by y. So that means I have x is going to be equal to y times tangent of 68. Now, some of you might be like, why don't we calculate that tan 68? Because we're going to be introducing decimals when we don't need to yet. So let's just leave it the way it is. So we got an equation, but I can't really solve this. So like we did in prior units, we're going to label this equation. Let's call this equation number 1. Can we create another equation? Well, we have another angle. Maybe we can work with that. So let's create another equation. So in this case, if we're labeling our triangle, that's big triangle over here, the whole thing, then we have 44. We have our opposite, which is still the x. We have our adjacent, which is down here, and we have our hypotenuse. We have no data on the hypotenuse, but we do have data on the adjacent. So we're looking at opposite and adjacent. So we have tangent again. All right, so let's write out what we can this time. Tan of 44 is going to be equal to our opposite, which is x, over our adjacent, which is 20 plus y. Okay. Well, let's isolate. Let's isolate for x again. So we're going to multiply both sides by 20 plus y. So x is going to be equal to 20 plus y. That's all one term. Multiplied by tan of 44. Oh, interesting. So what am I looking at here? I got two equations that are equal to x. Let's label this equation 2. like you do when you have two equations that are equal to the same value, you can just set them equal to each other. Really what we're doing is we're going to sub one equation into the other equation. So let's sub 1 into 2. We're going to sub 1 into 2. Okay. So that means wherever I see an x in 2, I'm going to put a y tan 68. Okay. So there's an x. How convenient. Y tan of 68 is equal to everything that's on the right-hand side. So we have 20 plus y times tan of 44. Well, this is a two-part term, 20 plus y. So how do we normally solve this? If tan of 44 was just like a value, like a 9 or an 18 or something like that, we would distribute. And that's what we're going to do. We're going to multiply each term inside the brackets by tan 44. We're basically going to distribute to each component within that term. So we'll leave y tan 68 all alone. We're not going to touch this thing right now. Y tan of 68. Okay, that's a terrible end. And then we're going to multiply through. So that means we have 20 tan of 44 plus y tan of 44. Okay, so what can we do now? Well, we can start collecting our terms, bring everything together. So let's do that the best we can. So let's bring our values with y together. And we'll leave our 20 tan 44. If you think about this, this is really just a number. Tan 44 calculates to a specific value, and we're just multiplying that by 20. That's just a number. Whereas over here with the y components, we actually have a variable. So let's bring our variables together. We're going to collect our like terms. Okay, so that means we have y tan of 68, 68, minus, because it's being added here, y tan of 44. And on the right-hand side, we still have 20 tan of 44. Now, what can I factor out here? I can factor out a y. So from both terms. So that means I have y is equal to tan of 68. Oops. I don't know why I did that twice. Minus tan of 44 is equal to 20 times tan of 44. Now I want y all on its lonesome. This is one term. This whole thing is one term. So if I want to get rid of that one term, which is currently being multiplied by y, I'm going to divide both sides by that entire term. So I have y is equal to 20 tan of 44 divided by that whole thing. So we have tan of 68 minus tan of 44. There we go. And now we can actually just calculate this because this is nothing but numbers here. There's no variables on this side. So you type that into your calculator. You're going to need lots of brackets when you do this. But when you do so, I'm going to surround this in a set of brackets, so that'll help you out. When you do this, you're going to end up with a number. Remember, this is to the one decimal place of 12.8 meters. We now know the value of y. Awesome. Now we have to calculate x. How can we do that? Well, we can just substitute y into any one of our equations. Choose one. Let's substitute in our easiest one, which is number 1. So we're going to sub y into equation number 1. So we end up with x is equal to 12.8 multiplied by tan of 68. So we end up with x is approximately equal to about 31.7 meters. And that is the end of that question. So we had to incorporate a number of ideas that we've learned over the past. We had to incorporate our trigonometry that we learned this unit. We had to incorporate our idea of equations and creating those equations and then substituting to solve for that system of equations. This is not new information. We're just applying everything that we've learned throughout the semester. So that's it for this first lesson. The next one, we're going to be moving on to some new information. We're going to learn how to deal and solve triangles that don't have a right angle for a change. Not the easiest thing, but not the most challenging thing either. We just have to have a good memory.